Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of predictions from simple experiments. This is standard 7.6H in the great state of Texas, and we are using item number 1 of the 2025 released STAAR test. If we haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got a manager of an ice cream shop randomly surveying 70 children. All right, so if we add all of those up, right, we're going to get 70. If we add them all up, see that we can get 70 to all of those. And we're trying to figure out what statement would be true about the next 350. So this is just a random survey. So we can make some predictions, but we don't know 100% for sure. If we're going to try to get 350, right, what we're going to do is we would just multiply that by 5, right? So if we multiply each of these by 5, we think if the next 280 answer the same way, our 350 would just be a version, right, proportional to what we already have. So that's kind of the thinking behind these experiments here, or these surveys. And so let's just read these statements. The number of children who select vanilla, so vanilla is 16, will be twice the number of children who select strawberry. Okay, so vanilla will be, so I'm just going to make an equal, twice the number, so 2 times the number of people who select strawberry, so 12. So if we can turn these statements into mathematical equations, then it's a little bit easier now. Does 16 equal 2 times 12? No, 2 times 12 makes 24. 16 does not equal 24, so it's not exactly twice. It's more than twice. So A is not working for us. B, the number of children who select vanilla, so 16 again, will be equals twice the number, so 2 times orange sherbet, 14. No, it's actually 2 plus 14 makes 16. But even then, a multiplicative relationship would hold if we multiply everything by 5 to get to 350. An additive relationship would not. So even if they did say 2 more, I would still say that's incorrect because it's 2 more now, but they would get farther and farther apart. They wouldn't maintain that distance of 2. So that's not going to work for us either. All right, the number of children who select chocolate. All right, so chocolate is 28, will be twice the number of children who select orange sherbet. There we go. 14. So that's definitely looking like something. 2 times 14 does equal 28. Let's check D, and then we can test it if we actually multiply it by 5. Okay. The number of children who select orange sherbet, 14, will be twice the number. Children who select strawberry. Strawberry is 12. Nope, this is another plus 2. But that plus 2, rather than multiply by 2, still wouldn't work when you take it out by 5. So I think it's C, but let's actually multiply. So we've got chocolate and sherbet. So we're dealing with this number and this number. Okay? So let's multiply 28 by 5. So that's going to be 40. It's 10. That's 140. And then let's do our 14 by 5. So that's going to be 20. And that's going to be 70. So you see here, even if we did 350 children in our next survey, and all of these were multiplied by 5, you notice how this 140, this chocolate, is still twice the number of the children who select orange sherbet. So that's that multiplicative relationship we were talking about. You can multiply each by 10, and you would still get twice the number. So the multiplicative relationship holds when you scale up or scale down. So our answer here is C.